is Anil Kumar, Faculty of Digital Electronics. We are learning a concept called encoder. Sir, we have two types of encoders. We have seen in the previous lecture already, and we have learned a basic encoder already. And now let us try to understand a priority encoder, one of the topmost important topic in entire digital electronic circuit. Very simple, a very small concept, but it is having more weightage based upon its logic. And if you want to verify the previous exams question papers, there are many a times this concept is asked, and the only one logic we will try to understand. Make a heading priority encoder. Sir, priority encoder. Priority encoder. It is a combinational circuit basically. Let me write the first point. It is a combinational circuit. Combinational circuit. Even this priority encoder is also not having any kind of feedback. It is also not having any kind of memory, and its present input is completely depends on its present output, and it should not have any kind of synchronization. Even the all things whatever are applicable to combinational circuit, those kind of principles are applicable even to priority encoder. Sir, in basic encoder we have studied and we understood. In basic encoder, only one input, when we are trying to giving one input, that particular input will be go out to output. What is the encoder main particular principle? It is used to convert all other codes to binary codes. We can say octal to binary, hexadecimal to binary, even decimal to binary. It is used to convert the basic other codes to binary codes. In the process of conversion, only here basic encoder will convert only one bit in a sequence process. We can say that first of all it will convert 0th bit, and it will convert first bit, second bit, third bit, fourth bit. We can say I0, I1, I2, I3, I4, I5, I6. In a sequence, it is used to convert one bit to here other codes to binary codes. Whereas priority encoder, the moment when we apply two or more inputs at a time, and I want to convert all these three inputs immediately, not in a sequence, so that the moment when the requirement comes, when emergency comes, automatically we will use this priority encoder, and based upon this priority encoder we will try to convert the input to output. We can say other data to binary data. Sir, how this principle, what is the principle of this priority encoder is, if you see here the topmost priority, we can say highest weightage, we can say highest input will be first of all considered, and then this topmost prioritized bit, or we can say highest weightage bit, will be converted into binary. Sir, how this process will be happen? Let us try to understand. This is a important point. When multiple inputs applied, highest priority will be goes to highest weightage bit. Weightage bit, or we can say weightage input, we can say. This is the thing. The only important statement is this. And now if you see the number of inputs and outputs, we can say here the number of inputs and outputs will be defined based upon the type of priority encoder. If you see here 4 into here 4 into 2 priority encoder, the number of inputs will be here 4 into 2 priority encoder, suppose, then the inputs will be, we can say that, then the inputs will be here, number of inputs are, we can say 4, and number of outputs are, we can say 2. This is what priority encoder. And now coming to the circuit diagram. Here the circuit diagram, if you see, here there is a 4 input and 2 output circuit diagram. We can say 4 into 2 priority encoder, we can say 4 into 2 priority encoder. There are 4 inputs, we can say all these are I0, I1, I2, and we can say I3, and output is this. There are 2 outputs, we can say Y0 and Y1. So here every encoder or a priority encoder consists enable input. This is the circuit diagram. And now based upon the circuit diagram, let us try to draw the truth table. So here the truth table is very, very important. The third point is truth table. Here the truth table is very important. Here to draw the truth table, sir, as like a basic encoder we have seen. Now there are things, let us try to list out. The first thing is enable input, and now the next inputs are I0, we can say I0, I1, I2 and I3, and now the outputs are, we can say the first one Y0 and Y1. This is the truth table structure. Let me draw it here so that we will understand. A very, very important topic. Here, sir, as like a basic encoder, suppose if you make enable pin is 0, enable equal to 0, what it means? There is no established connection between inputs and outputs. Here there is no established connection between input and output when we make encoder. Enable input is 0. So that here all inputs I0, I1, I2, I3 will be 0. Because the inputs are 0, automatically outputs are 0. That is the first thing. And now coming to the moment when I change enable input is 0 to 1, automatically enable input is changed to 0 to 1. Automatically what will happen, sir? Here enable is 1, so that automatically here I0 will be enabled. We can say that I0 equal to 1 and all remaining inputs are zeros. We can say I1, I2, I3 are zeros. And now so that based upon the input we can say here I0 is 1, so that automatically I0, so that both will become 0 zeros. The data will be converted to, we can say that here binary 0, because this is zeros input. And now the coming to the next one, here enable input is again 1, and now here we will try to make I1 is 0, I1 is 1, and all remaining things are zeros as like a basic converter. And now sir, in enable here priority encoder, only the important thing is, in priority encoder the important thing is here it will take only top, or we can say highest weightage bit as a input. When we apply 0 and 1 as inputs, it will consider only 1. When we apply 1, 2, 3 are the inputs at a time, it will take only 3 as a input, because that is the topmost weightage bit out of all available applied inputs. So based upon this reason, we can say when we apply I1, automatically I2 is 0 and I3 is 0, and below the level, here I1 is a topmost priority, so that the below level is, we can say I0. I0 will be entirely, we can say disabled, not even 0, it will be disabled. That is the only concept that we need to understand in priority encoder. Sir, here suppose if you can apply enable input is 1. Here sir, here let me take I2 is 1 and I3 is automatically 0. Here the topmost priority is I2. So now here I3 will be 0. And now what about the less than I2 priorities? We can say I2 is the topmost weightage bit, and now we can say I1, I0 are the lesser weightage than I2. So all these two bits will be disabled. So that is the case that we need to understand. So here coming to the fourth one, enable input is 1, and now here we can say that I3 is 1 and all remaining, there is no other highest priority than I3 here, so that remaining all are lesser priorities than I3. So here I0, I1, I2 will be completely disabled. So this is the truth table of priority encoder. Sir, when we apply I1, it will become 0, 1, and when we apply input I2, automatically 1, 0. When we apply I3, automatically 1, 1. It is converting the other data to, we can say, binary data. So this is the truth table of, we can say, priority encoder. Based upon this truth table, let me try to write the logical equations. Sir, here the logical equations are, we can say, fourth one, logical expressions. Logical expressions. Logical expressions. We can say we have two logical expressions because we have y0 and y1. The first output is, we can say, y0. What is the here enabled outputs are here? These two are the enabled outputs. What is the corresponding inputs are here? The corresponding input is, we can say, I2. I2 is the corresponding input. And now here plus, we can say, I2, and now here I3, we can say plus I3. This is the, we can say, basic output. So here the important thing is, out of I2 plus I3, we need to write even for 0 also. Here these two inputs are completely blocked, and now this is enabled input, and now this is disabled input. Now for this particular disabled input, we need to write the output expression like this: I2 plus, here this is I2, I3. So I3 is 0, I want to write it as I3 bar. That is the only thing that you need to remember. Plus I3 bar, and now here the second one is I3. So this is the final output expression. And now coming to Y1, if you see here Y1 equal to, here what are the enabled outputs are here? This is 1 and this is also 1. The corresponding input is this one, I1, and now here also the corresponding input is 1. So now, sir, let me write it as 1 I1 plus here this one is I3. Now here what are the blocked inputs, sir? I0 is blocked and I2, I3 are disabled. So that I will write it as I1 plus here I2 bar, I3 bar. I2 bar, I3 bar, and now the second part is I3. This is the output of Y1. So this is the priority encoder analysis. And now we can analyze even for 8 into 3 priority encoder and 16 into 4 priority encoder also we can analyze. The only thing is here the highest priority, whatever the highest priority input is there, that will be selected as a output, that will be converted into binary output. That is the proof of truth table. Thanks for watching. Please do subscribe.